important tools in the chemist's toolbox. Do you know why? Just one look at the position of any element in the periodic table gives a lot of information about all its properties. How? Well, let's find out. In 1913, a British chemist, Henry Moseley, rearranged the then known elements in order of increasing atomic number. From this emerged the modern periodic table and the modern periodic law, which states that properties of elements are a periodic function of their atomic number. Let us recall that the atomic number is the same as the number of protons in the nucleus of an atom. Does hydrogen atom have any neutrons? Helium has 2 neutrons and 2 protons. What is the atomic number of helium? The atomic number increases by 1 from one element to the next in the periodic table. Hydrogen has atomic number 1 and neon has atomic number 10. Elements, when arranged in order of increasing atomic number, lead us to the classification known as the modern periodic table. By arranging elements in this way, scientists were able to pick out patterns, and the properties of other elements could be predicted with precision. The position of each element in the periodic table can be defined by 2 methods: by giving its atomic number, or by indicating both the group and the period in which the element belongs. The modern periodic table has 18 vertical columns known as groups. And 7 horizontal rows known as periods. How are the elements in a group related? All elements in a given group display similar properties. Elements in a group undergo similar reactions with other substances, forming compounds of a similar composition. Why do elements in a group show similar chemical properties? Is it because they have the same number of valence electrons? To understand this, let's take a look at group 1 of the periodic table. Note the electronic configurations of 3 successive elements of group 1, lithium, sodium, and potassium is similar. All elements in group 1 have 1 valence electron. Shall we see if the elements of group 2 share a similar property? Let's look at the electronic configurations of beryllium, magnesium, and calcium. These elements each have 2 valence electrons. What we have observed is that the number of valence electrons is the same for all elements in a given group. This is true throughout the periodic table. The reason the periodic table is one of the most important tools in a chemist's toolbox is that it can be used to predict the electronic configuration, the number of valence electrons, and the chemical properties of any element. Is there a relationship between the group number and the number of valence electrons? For groups 1 and 2, the group number indicates the number of valence electrons in an atom of a given element. Now, let's take a look at the electronic configuration of the elements of group 17, the halogen. The elements fluorine and chlorine each have 7 valence electrons. For elements belonging to the groups 13 to 18, the number of valence electrons is equal to the group number, minus 10. Do all elements of group 18 follow this rule? Helium has only 2 valence electrons, unlike other elements that have 8 valence electrons. What is the valency of group 18 elements? Hence, we can say that groups in the periodic table share an identical outer shell electronic configuration. Is there any common feature that links the elements in a given period of the periodic table? Let's take a look at the hydrogen atom. It belongs to period 1. Its atomic number is 1. It has 1 electron and 1 electron shell. The second element in the first period is helium. Its atomic number is 2. Helium has 2 electrons, and they both occupy 1 electron shell. Now take a look at lithium. It is the first element in period 2. The atomic number of lithium is 3. And its 3 electrons occupy 2 electron shells. Now let's take a look at the other elements in period 2. For instance, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and finally, neon. All have 2 electron shells. The successive electrons are added to the second shell, which can contain up to 8 electrons. This regularity can be seen throughout the periodic table. Let's take an element from the third period. For example, magnesium. The atomic number of magnesium is 12. Magnesium has 12 electrons. The first innermost shell of magnesium contains 2 electrons. The second shell contains 8 electrons. third shell contains the remaining 2 electrons. So, magnesium, which is an element placed in the third period, has 3 electron shells. This suggests that the number of electron shells in a given element equals the number of the period in which the element is found.